Hello, everyone. Thank you for joining a bit early. Good to see you all here. Welcome. It just says IG789. Can I know your name, please? Yeah. Okay, I see everyone joining, and you also see Agent Varsity bot here. It's a bot to help you, which can help you answer questions. So if you guys have any questions, please do ask your Agent Varsity bot. Feel free to share about your background what your background is. Agent Versity Bot will probably customize all of your responses, all of your answers accordingly. If you're a business owner or maybe a software engineer. Um, okay. So Agent Virtual Bot is a hyper personalized bot that can help you learn something, a different concept, probably something that is um, customized to you. All of these answers customized to you. So we'll start the presentation in a bit, maybe after a couple of minutes. So if you feel free to just post what your background is. This is supposed to be a call where we learn about new things, and we usually have this every week nowadays. Like we're doing it every week. Next week we have something on AWS. And after that we'll be planning something on Azure, and we're going with different cloud providers because I did see a lot of interest is there on the cloud providers. We do have some different channels that you can subscribe us for various news. So please do feel free to subscribe us on LinkedIn or YouTube where we post our videos. So we do have live stream of this event on YouTube, LinkedIn, and even on X. So don't worry, this meeting will be recorded. So feel free to share your background, maybe your brief name, what's your interest, all of that. Anyhow, I'll be publishing a poll here that you can answer. You all can see a simple poll that help us to gauge the background or at least the demographics that who are attending this call so that we can further fine tune our presentations for the next meetings. Yeah, just going to give a couple of more minutes and then we get started. And during presentation, if you have any question, please do post that question in the chat. I'll pause for a few minutes and answer those questions. Maybe once I'm done with half an hour of the presentation, and then we'll have ample amount of time to ask or have a discussion. So feel free to post your questions on the chat so that we can have a detailed discussion about it. Okay. So Okay, so let me go ahead and share my screen. Let's get this started. Um, I will be moving around a bit today in this call, not just pure slides. I might have to present a notebook for all of you to um, showcase what we could do with a note mainly with a notebook. Um, you all can try that notebook and see how GRPO in action. You could actually see the reinforcement learning in action. Okay, so let's get started. So today we're going to look at agent reinforcement learning trainer. So I don't know how many of you have worked with agents. If you have worked with agents, please, have an heads up, or maybe you could just say thumbs up or yes. Um, in the chat. If you have already worked with agents, definitely you can relate some of the concepts that we're going to discuss here. But if you're really new to agents, you haven't ever done that, yeah, I do see quite a few thumbs ups. That's nice. So these agents, we're going to see like why do we need reinforcement learning for agents? Because um, we can have an agent work well by having different prompts. You can tune different prompts. You can make them work according to uh, your end goal. So you can have an agent, maybe it could be a travel agent, a sales agent, any AI agent which is actually using LLMs under the hood. I have to be very specific on what agents I'm referring to because agent could mean many things based on the context. So these agents are basically an LLM uh, backed AI agents which can perform specific actions for you to, book maybe doing travel planning or addressing any of your queries in sales tickets, working with sales tickets or anything like that. So we are going to look at some open source library called ART, but it actually making reinforcement learning really easy for anyone who is an agent builder to adopt this library to build AI agents and optimize AI agents with reinforcement learning. So if you're really new to reinforcement learning and you are a developer, I mean, and you already developed some AI agents, I think this will be very valuable to you because you could actually make use of um, this library to make your agents work really well. Most of the prompts are really brittle, so you will understand that eventually as I go through the presentation. I'll tell you why AI agents do need reinforcement learning, and you see now a lot of agentic RL workflows have been developed. Um, yeah, so today we're going to look at, and most of these slides are all done with the help of AI itself. So I've used ChatGPT to do all the slides development as well. So if there are any mistakes, please do. I mean, I did review all of the slides which are built by ChatGPT, so there'll be no mistakes. But even if they are, please excuse me. So let's go ahead and look for what is an agenda today. So we're going to look at pre-training and post-training just to give a fundamentals on how reinforcement learning is applied to a large language model. Um, and what exactly is post-training and why do we use reinforcement learning there in the post-training process? Why do we need reinforcement learning for agents? Going a bit brief on GRPO, which is an algorithm for reinforcement learning it's introduced by DeepSeek. We're gonna go through that a bit, how it works as a pipeline, and also how the library actually works and helps you out in integrating reinforcement learning to your AI agents. So pre-training is when your LLM has been trained with a lot of massive amount of unlabeled data just to predict the next token. So that is something that all of if you're familiar with ChatGPT, the model that is powering ChatGPT is GPT-4 or GPT-3. These are some models that they train. ChatGPT is actually a product, but I kind of say ChatGPT in my presentation just so that someone who doesn't know what an LLM can relate. We're actually going ahead and uh, seeing how a model that is powering ChatGPT is trained. So we just a simple brief introduction of that process. So pre-training is when how that model is trained to to be able to produce data or produce output that is uh, reasonable for humans to understand. Uh, the pre-training process is when you pushed train the model with large amount of unlabeled data, mainly internet scale data, huge amount of data. The model learns, how the language is. It learns grammar. It learns world knowledge, like how different words are related and everything. It can it can have some limitations because it can produce language, but sometimes it might produce different languages together, or it might do some blunders, or it can hallucinate. It doesn't might not follow instructions. It may not even behave like a chatbot. So that's a product of a pre-training LLM. So if a LLM, once it is pre-trained, once the training is done, um, it may not be useful to us humans. Then comes the post-training process. So post-training is when a pre-trained model, which does was trained on a huge amount of internet data. Now, in order for that to be useful for humans, like maybe like something like ChatGPT, when you ask it to go out and give you an email or try to summarize something or even write or prepare the slides, right? So it was able to do that because it was fine-tuned with instructions. It was fine-tuned to give a lot of reasoning traces. It is fine-tuned to produce quality data that anyone can actually understand. It does have its tone, how to respond to a question, and different aspects that actually make sense to a human. Right? That is what something that post-training does. And uh, AI or OpenAI used RLHF, which is reinforcement learning, to do that post-training process that actually enabled these huge LLMs, which have been trained with large amount of data to produce output which is reasonable. That's post-training process. And post-training doesn't require huge resources as pre-training. Pre-training does require a lot of resources because the model is learning grammar, it's learning languages, it does make sense of like different alphabets. It does know a lot of this, it does know how these all fit in one sentence up there. It's basically predicting the next token. So it does know, after seeing so many examples, it's able to do that. So in post-training, how the post-training is done. So basically, um, all of the huge models, this post-training is done with reinforcement learning with human feedback. So we basically have a model giving some examples on how it has to respond if, maybe giving a interaction between a human and a chatbot and a human, maybe like 100 or 200,000 examples of those, and instruction fine tune them. So you're saying, hey, if this is a question, this is how you need to respond. This is the question, this is how you need to respond. So you're basically asking it to respond in a way that we humans can understand and interact. So the behavior change is what we are trying to enforce in the post-training process. I'm just talking about the LLMs, not the AI agents yet. It's just about the LLMs, how they've been trained using post-trained using reinforcement learning. And they are usually, any reinforcement learning is accompanied by a reward model. I mean, I'll talk a bit about reinforcement learning in the next slides, like what is it, how it works. But I just want to give you a brief about this. There is something called a reward model. So reward model is, since it is a human feedback, we human saying it's good or bad. If the response is great, then it got a reward there. If the response is bad, probably it will go back and now generate the response in a different way so that it keeps on improving itself, just like all we humans grew up from being, a toddler all the way till adulthood. It's all through reinforcement learning, experimenting with something and then learning from the feedback and then improving ourselves, right? It's the same thing happening in this as well, in these models as well. A reward model, and then there is something called a RL process, which is PPO. I don't want to go too deep into the PPO process. It's one of the process to optimize these rewards. Optimize with rewards, I mean, you are basically applying a feedback loop, and then you are fine-tuning the model. So fine-tuning a model is just changing different weights in the model, different numbers in the model to make it align with, or to make it usable to produce, just like how ChatGPT is producing emails and or whatnot. So you're basically fine-tuning that process with these human preferences. So, and this process is also a bit biased. Like if you see most of the ChatGPT provided generated output, most of this human feedback is actually done from certain sections of Africa. So who have actually provided feedback on this ChatGPT, initially ChatGPT generated responses. I'm talking about GPT-3 era. You would see some words are really predominantly used in that region. And you could actually see, because of the human feedback, ChatGPT actually learned to use those words more frequently. And that's definitely, these are the ways in which, someone can detect is that AI generated or not, because these words are frequently used because it was post-trained and the feedback was actually given by humans, and they happen to give a thumbs up on some words that they use regularly. So there is definitely a bias. Most of these outputs are. So I do see a hands up from someone. I think it's Rahmana.
Yeah, I just have a question. Like when we talk about the pre-training model, pre-training LLM, so basically we are, so that is like kind of unsupervised learning, where we do not have any ground truth, right?
It's I can say it's self-supervised learning rather than unsupervised learning. Yeah, definitely yeah, self-supervised learning is also a section of unsupervised learning. Yeah, definitely it's unsupervised learning. It doesn't have ground truth. It just tries to learn different parts. It just trying to learn grammar. So the reason why I call it self-supervised learning is because um, language in itself, like when you give, maybe you train the model in bunch of, yeah, with bunch of examples. Maybe if you want the model to learn a language, if you remember fill in the blanks, have you ever learned about fill in the blanks when you're learning English or
Yeah.
any of these? Yeah, fill in the blanks, like where what should be that word that fits in to make the output really meaningful. So
Mhm.
we also create data with that. We mask some words and then we feed the model with that and train and give it certain examples. We try to see what is the prediction of that word, whether is it able to get that right word because of all the data that it has. So it's definitely unsupervised learning. But to be more precise, we call it self-supervised learning. But that makes the model more scalable because language domain is pretty standard because we have to use words in a specific way. So that's what it is. But yeah, it is a part of the unsupervised learning itself. And if you make it something supervised learning is not scalable. And especially in domain like not natural language NLP, I don't think it's not possible to do all of this. You can't keep labeling everything, right? It's
Yeah.
it's huge. It's huge. So yeah,
There is
if
another
you probably
question.
do, yeah, go ahead, go ahead.
Yeah, thank you so much for answering this question.
No problem. No problem.
The second question is like when we are talking about the reinforcement learning, which is like the post uh, learning for the LLMs. So uh, one stage when it is done would be by the companies like OpenAI who will be training the models. Can we do as well by using like the quantization or all those kind of things? Can we do these things at our own end with limited resources as well?
Yes, we could do that as well. I mean, there are a lot of people who do that because, see, as of now, most of this post-training process that all of these vendors are doing is for someone to behave like a chatbot, right? Everyone is using this because we are using it to behave like a chatbot. So that's the reason why most of the post-training process is mainly aligned towards to make the model behave like a chatbot. So imagine if the model is already trained on huge amount of this data. Now you can make it behave maybe more of like a chemical or organic chemistry molecule rendering thing, or maybe something that is spitting out to be like a creating designs or maybe some kind of data. So you're not making that model behave like a chatbot, but you're making the model behave a bit differently. So a lot of them do that, and you could also do that post-training process because it requires less resources. There are ways to do that. There are different. The only problem is when you're doing full fine-tuning of huge model, because when you do post-training, once a model is aligned, so they call it a base model. So once a model is done through pre-training, they call that model as to be a base model. And from there, you fine-tune that model to, either to follow instructions. They call it an instruct model. So if you go into Hugging Face, you would see all these different types of models. If you see a base model, the base model doesn't behave like a chatbot. It's up to us to do post training and make it behave like a chatbot. Or if you want to make that model just to be more independent of doing some scientific research, you could probably start with a base model and then use data to fine tune it or post train it to be something like a researcher, because now it doesn't have to reply to someone like a human asking a question, it's replying something back. So, or you could even make the base model and just make it work on a different domain itself altogether. Maybe it already knows different languages. Maybe you want to make this model really proficient in Japanese because it already learned a bit of Japanese, but you can do post training only to Japanese so that the model can be more proficient in Japanese itself, right? So you could do that post-training process. But there are different ways to do that. And you also use something called LoRa, because if you want to make the model fine-tuned with less resources, there's something called LoRa fine-tuning process that you could go with by introducing additional weights and fine-tune that in a certain way. But yeah, you could do that. You can basically do that. You can find a lot of base models in Hugging Face, and you can start with them and make them post-training. You need significantly less resources to do that.
Yes, thank you so much. Last question, please.
Sure.
So one approach is like the reinforcement learning that we are dealing with right now. The other way, which is like the RAG way of like training the LLMs
Mhm.
to like to a specific domain and give it like train it with that knowledge. So which one is more proficient? Like which one is more accurate? And is there any kind of distinction in this situation? Go with this type of approach, and then other situation go with the reinforcement learning.
So, so yeah, that's a great question. So RAG is basically you're trying to once the model is post-trained, RAG is basically adding more domain knowledge, right? Maybe you have a domain already that you have your own knowledge base, and you're actually training the model to answer your questions using and in that case, you're still relying on LLM, and this LLM is actually trained with different kinds of examples or a lot of data, and it just basically learning a lot of patterns. So there are two differences here. One is RAG can basically retrieve additional knowledge, but still RAG is just that you're basically doing context engineering. You're adding a bit of more context so that it answers your question. And if those documents happen to be something internal documents, you're actually still having the model work on that knowledge and give you an answer back, right?
Okay,
So
and we are not
that's
changing the
RAG
weight.
is.
Yeah, so
We
we
are
are
not
not
changing
changing.
anything
Yes,
in
makes
RAG.
sense.
We're not changing
Yeah.
weights,
Mhm,
but in
definitely.
the other process, we might change weights. But also RAG or even all these agents are a bit more brittle because a prompt could change the behavior. Reinforcement learning. Let's say if you want to build a model that can actually do mathematics, right? It can actually do math, like calculations, how we do in our brain. Models are really very bad at it, right? Because these models are just learning from training data. So if you ask it to do some calculations, they might definitely hallucinate because they might have seen the training data a lot of amount of times like during training process, so they can be biased. But now you can have reinforcement learning, which can actually make the model do math by using like different tools. I mean, I'm talking about the agent space. Once you give it tools, or even the LLM only to do reasoning. Let's say if you want to analyze a problem and solve a problem in detail, reinforcement learning will help it because now it can do more reasoning, and it can also break down the problem and solve the problem by breaking down the solution. So that's something that you could do with reinforcement learning. RAG, you're not changing any weights. It's just the same LLM, but your RAG is more of context engineering. Yeah, hopefully that answers your question.
Thank you so much.
Yeah, no problem.
I
So
have a quick question, if that's okay.
yes, just go ahead.
What do you need to do post-training for the model?
Why do we need post-training for? Is the pre-training process is only aligned to the pre-training process would only allow the model to learn the language or some grammar. It does have different knowledge, but the model would not produce the output. Um, it will just predict the next token, but it is not aligned to our preference. So if you go and ask a base, first thing is we can't chat with the base model because the base model just knows it is based on it does know how the language is, but it is not aligned towards human preferences. So
Okay.
that is the thing with pre-training. So that's the reason where post-training is required, where we are changing the behavior of the model to be more of a chatbot, or you're asking the model to follow some instructions, and also telling the model to do reasoning. So all of these traits are something that we can do as part of post-training, and we don't need huge amount of resources to that because the model already knows how the language is. Only what you're doing is you're giving some examples. So there is two types of ways in which you can do that. You have reinforcement learning to post-train the model, and also supervised fine-tuning, which is you're giving a lot of examples and just telling it, hey, follow. I give you 100 examples or 100,000 examples where how you have to behave like a chatbot, and now you're making the model behave like a chatbot. So that is all part of the post-training process, which doesn't require a lot of resources, but you're at least aligning the model to behave like a chatbot or behave like anything other, maybe any other behaviors as well. So that's
Okay,
the
so
difference between pre-training and post-training. So it's a model that is
okay.
pre-trained. It's called a base model, and the base model
Mhm.
cannot. I mean, you cannot. If you ask a base model to generate something, it just generates gibberish as well. It might mix up English with Chinese. So that is that is
Okay.
how it can produce output. Yeah.
Okay, thank
Yeah.
you. So you need a bunch of so what do you need exactly to do the post
You
training?
need, so in post training, let's say you want a model like ChatGPT, you want to build a model that's powering ChatGPT. You might get instruction set. You will say maybe a question and an answer, a question and an answer. You create 100,000 of those question and answers across different domains, right? You can get like
Hmm.
maybe 40,000 questions and answers for English, maybe 100,000 for mathematics, maybe another 100,000 for maybe science, another 100,000 for biology, and you just give these post-training questions and have the model align with that post-training process. So the model learns how to follow a specific, let's say if you go and ask a model to just go and summarize something, or just go and find out some specific or maybe find out important points from a summary from a meeting instruction, you can probably teach that to follow those instructions, right? That is what you're doing. You're telling the model that, hey, if a chatbot, how a chatbot responds back, right?
Hmm.
In which way it has to respond. And also reasoning as well. Reasoning in the sense that given a problem, how do you break down the problem into different steps? Right? That is what's going on now with ChatGPTs and all of these reasoning models. So that's all part of the post-training process where the reasoning itself is something that the models get, that models learn, and they are able to reason a problem. Given a question, they're able to break down the chain of thoughts on how to solve that problem.
Hmm.
I don't know if you have ever worked with reasoning models, Rose.
No, I'm not a developer. I'm more on the
Okay.
non-technical side. So yeah.
Okay, no problem. But yeah, that's what it is doing in the post training. It's just around
Okay.
reasoning, instruction following, just like how we might teach a kid to learn,
Yeah.
how to, answer questions. We're just teaching that. So here we are basically creating a lot of labeled data and telling that, hey, this is how you can learn. Align tone, how to talk in an
Hmm.
empathy way, how to, and domain knowledge. Domain knowledge is maybe domains across domains. It could be biology, math, science, arts. It creates that domain knowledge as well in this post training process. So
Okay.
that's
Thank you
what's
for explaining
doing.
that. Thank you.
No problem. Thank you. So, but reinforcement learning could be a broader domain. Um, yes, Sam. See, tuning is possible only if the model is open. Yeah, that's right. I'll probably answer that question once we're done with a few more slides. But so reinforcement learning is just like I mean, reinforcement learning is applied across. It's been there for a very long time. It's applied in robotics. There are a lot of areas in which we use reinforcement learning. And simple way how it works is maybe a kid learns to never put hand or never touch a fire. The reason how they learn is maybe they interact with different environments around the home, and one day they just go and touch a hot surface, and they know now they should never do that because they got a negative reward, right? It's hot now. I should never do that. It might burn my hand, and the kid never does that. It never does that. That is a learning loop, right? Reinforcement learning is how our brains learn. So it's if everyone's familiar with that, it's just that we're applying that now in a digital space. So agent is anything that is learning. There is something called an environment. Environment could be, maybe if it is a kid, it is a house, that's an environment. If it is a robot, then they could also have a simulation. Like most of the Teslas, the reason how they are able to drive in a full self-driving mode is they get trained in simulation. They're trained in games in the cloud. So a Tesla car can go make different actions and they get a reward and they learn. And that is how a Tesla can actually learn to drive, but they are actually learning millions of times in the cloud because this is the agent or the model that is sitting in your Tesla that's able to take this different decisions to drive you safely. So that's how things are done through reinforcement learning. And and there's also game playing as well, chess and Go. These are other domains in which, you can, I don't know if anyone of you know AlphaGo. AlphaGo is something that happened in 2016 or 2017 by DeepMind. They were able to beat world's top Go player by using reinforcement learning, all pure math. They just use reinforcement learning. They have the model see millions of games, and the agent, which is just a software, in the reinforcement learning space, that learned how to beat someone in Go by learning Go all by itself. We didn't put instructions. We never say, hey, this is how you need to perform a specific, we never hard coded the stuff. We just have the model see different games, maybe thousands and millions of these games, and learn from its mistake and learn Go. Go is a game like chess, but Go is even complicated than chess. It's a huge, it's a complicated game played in China. So it's from China. So that's what an autonomous systems like self-driving cars, that is how they are already. And robotics and automation. All of the robots learn how to perform specific actions all through reinforcement learning. So reinforcement learning is there for a while, but you might think how this is applied in our in the language domain space, right? So, so basically in the language space, as we previously learned, the agent in our case is a language model like an LLM. It generates different text, and now you get a human critic, a human that goes in terms of RLHR, which is reinforcement learning with human feedback. A human would give a feedback, and it goes back and make it updates. The updates is nothing but back propagation or changing the model weights, or maybe just doing some math internally, some numbers it changes to understand and learn the way to generate some text. So that is how it's able to learn how to respond in a proper way. How to if you ask the ChatGPT to just say, hey, can you respond and make this response with a bit of empathy in it, so it can do that. You can ask it to just go and maybe crack a joke, or maybe have some different dialogues, maybe summarize something. So these are all different ways in which you can have a model teach to teach different skills. So that is how you can make this. That's how you can have this reinforcement learning applied to a language space. In reinforcement learning, they say it's a policy that the model learns. In the language space, it's a language model whose weights are itself are policies. If you don't understand this, just ignore, because if I want to go and explain what is a policy, it might take a while. So I just want to just touch through this. Policy is nothing but the model weights that it is changing to change its model weights, internal states, you can say, something that's going on internally to to perform better next time, because it got a bad reward if in case it not generated a proper joke. Instead of a joke, it generated a sarcastic joke. Then probably you are penalizing it, and it goes back and updates its model weights and generates something new now. So this is how the model learns, or these LLMs learn how to reason, and they get a lot of this behavior. So why reinforcement learning for agents, right? I mean, LLMs, we understand. The difference between an LLM and an agent is, so agent is, um, let's say ChatGPT is just a chatbot, right? If you ask ChatGPT to just go ahead and book a ticket, I don't think it can do that, right? But you can make it do that, maybe by giving it access to maybe your wallet to make payment, to go out and do some actions on behalf of you. There are a lot of industries are already doing this. Like you will see so many startups saying, "Oh, we are agentic AI startup. We do agents. We build agents." It's a huge word outside. So all they're doing is basically having this LLMs, which are already pre-trained. They already have a lot of this behavior, but they don't know how to use tools, because you might have an LLM. It is more generalist. But let's say if you want to build an AI agent, which is just doing a travel booking tickets, a travel agent which knows, it does the planning of your travel, and it has to go out and book a ticket. So booking tickets is not straightforward. First thing, you have to look for your flight. You have to look for different airlines. You have to look for the cheapest one. You have to look for all the preference of the human, and then go back and click on a button and make a payment. And once the payment is done, you have to verify if the payment went successfully, and then you have confirmation. So there are different actions that you need to do. So you have an LLM that can do planning, but if you want that LLM to not just do planning, but also go and act in the real world, to actually go click buttons or navigate to a computer, to go out and do research, or just create slides. I mean, these slides are actually created by ChatGPT's agent. I use ChatGPT's agent to do the slides. So it actually went in and created the slides by touching different parts of it and made this input. It added all this input into this. So it was able to do that because these agents are are something we know. LLMs, once they're given different tools, a tool could be a browser, a tool could be a computer, a tool could be a API, and then but how do we make that agent perform really well, right?
One small
It might
question.
go out. Yes, good.
So, are these tools, I believe these tools probably are also like somehow trained using LLMs, and they are not like just the plain tools. They are able to do some kind of smart decisions as well, and then they will be like integrated with the main LLM to give us the required results, right?
Yes, I mean, yeah, you do prompting, right? You're basically telling an LLM to do prompting. Are you basically tell your LLM to do you give instructions to an LLM how to book a ticket? You tell an LLM, hey, if you get this question on, go ahead and book a ticket. You have to go ahead and call this API to make the payment, right? So these are all information that a LLM has that information, but it cannot act on that behalf. ChatGPT can plan something for you, but it cannot just go and perform that action, right? These are the different tools I'm talking about here. So the tool is nothing but an API. It could be maybe if you have agent to do a huge calculation, LLM to do a huge calculation, it uses calculator to that calculation. It has to know that it has to use calculator because LLMs inherently cannot do huge calculations because they're lossy compression of knowledge, but they cannot calculate. You can go and ask, oh, can you tell me 100 plus maybe some number and tell me what is the result, or maybe tell me 1 plus 2 plus 5, what is the output? Unless they use a calculator, they can't tell that because the LLM or the LLM should know that they have a tool access called a calculator that has to call and then give the result back. So now they're improving themselves, right? They're actually behaving in a proper way and in a deterministic way because they should know exactly that they have this tool access and all of those. I don't know if I answered your question.
No, no,
You can,
that
you
makes
can,
sense. No, no, that actually makes sense. But I thought like these tools, like for example, doing some calculation on an Excel file, uh, probably that the tool, for example, the name of the tool is, for example, Excel. I mean that is not the
Mhm.
tool name, but for example, so I
Yeah.
thought like this tool also has some part of LM integrated with utilizing the Excel as well, or with like utilizing the calculator. So there is like I thought like there is a main LLM which does like call all these agents, and those agents perform their job. However, I thought like as per my understanding is like we need those agents are also not just like the like not maybe the like plain API calls. Maybe there is something also happening, like the code agents. They are like doing some kind of coding on behalf of the instruction given by the main LLM. So maybe some of them they are like intelligent, and some of them they are just like the plain tools, maybe.
Yeah, they are plain tools. I don't think any, even if it's Excel agent, yeah, they are Excel agents, by the way. Even Microsoft came up with Copilot for Excel. So, okay, Copilot for Excel. So what's happening? It's all plain LLM giving instructions to Excel through an API, right? Or maybe any other domain specific language because maybe LLMs does know how to write code, but if they just give all of these are wrappers. A coding agent is just a wrapper on VS Code. Cursor, okay, what is that? It's just a wrapper on an LLM. If you go and ask them how this is done, they are just talking to an LLM and giving the output. But they're just giving access to an LLM to act, to go ahead and create code, to write code in the IDE. They're just doing the plumbing between the existing tools, and a tool could be anything, right? It could be a VS Code, it could be Excel, API, anything that we humans are already using now. It could be your phone, laptop, because there are also computer use agents now. AI agent that just goes and controls your computer to do some task, right? That itself is a tool now. So all of this is powered by LLM. LLM doesn't talk to an external agent. I mean, yeah, you could, if in case you're creating a multi-agent system where one agent talks to another agent, and interactively they're doing something. But given an agent, the agent has access to a tool. It has access to memory because it should also know exactly what it has done previously. Because if in case it's a travel agent, it should also know exactly what it has done previously, maybe all your preferences, it should be able to store that. So these are different things that I should have access to. So that is what they're providing. They are using an LLM. They're providing a tool. If you are providing a tool as a VS Code, then you just build a coding agent. If you're giving that tool to be a maybe some access to a browser that can go out and do a travel booking and also make payments to different. I mean, that is what ChatGPT has done now, right? They came up with apps. So what they're doing with these apps, you just go and say, I don't know if you all know about this feature. Recently, they released something called apps. You can just go do bookings.com. Just can you go ahead and book this room for me? ChatGPT can actually do that now because they're just talking to booking.com through an API or through an MCP. I don't want to go into MCP because if you are not familiar with MCP, I don't want to go there. But if you already are familiar with API, which is just a way to exchange data with other systems, so they are able to talk to bookings.com and make a booking for you. So that is all. In that case, it's just that bookings.com side, yeah, there should be an agent on the booking.com side which will understand that. So bookings.com would probably get the instructions, but their agents would also work on it. In that case, yeah, there is a multi-agent system that are working on. But even there, it's all the LLM that's powering. It could be a different LLM, but it's LLM with different tools. So they are able to interact and perform that action. So you're just giving different tools to these wrappers of LLMs to perform actions on your behalf. Hopefully that makes sense.
Yes, it does. Thank you so much.
Yeah. So, so why do we use RL for agents, reinforcement learning for agents? Yeah, I mean, everyone who's an agent builder in this call, I mean, you might have done prompting, right? Oh, there is iterative prompting. You could do prompting to have your agent do it. You could have your agent perform really well with prompting. But, prompting is very brittle. Prompting can only get you up to a certain point. But if you want the model to truly understand the behavior, truly understand the environment, I'm talking about the agent to truly understand the environment, to how to do proper tool chain, maybe how to go ahead and use series of tools in a proper orchestration fashion. Then prompting works. I'm not saying it doesn't work, but RL can actually truly make your agent to learn that behavior inherently. You're basically not having it to follow a pattern through your prompts, but rather not just following the instructions, but also truly the model can be made efficient in your task. So that's what RL is for this agent. So it could either be like optimize end goals. It could be like it just not just mimic demos. It just means that you have a specific way in which you want to do a travel booking. You're just orchestrating all of this with a series of prompts. But in order to make the agent really truly able to use a specific tool, it can be done through reinforcement learning. And that is what we're going to see today. Like, how can we do that, right? I mean, you might have done prompting, but how can you do this? Like, how can you use RL for AI agents? Yeah, it teaches tool use, recovery, planning policies. These are all something that the agent itself learns from RL. It enables exploration to discover better strategies. That's definitely very important. That's something that RL already provides out of the box: exploration and exploitation. Online adaptation from live feedback is, you could probably do different kind of adaptations through different feedback. Maybe when you're doing an AI agent without RL, now you have a live AI agent. Someone goes and say the output is wrong. Now probably you go back and change your prompt and say, oh, there's an edge case. Let me just go and change the prompt. You could do that. It really works. A lot of people are doing that in production already. But if you have a live RL, it would work way better than having to do with a lot of this prompting, as prompting can be really brittle. It cannot always follow the same instructions. It is only 95%. Maybe sometimes it might follow, but you should also know the exact prompt or different things. So safety and constraints penalize hallucinations. If the model is hallucinating, you want to penalize it and just reduce that hallucination. RL can help. So these are different ways in which RL can be used for agents. Someone in this call who are not just familiar with this may be surprised. I'm pretty sure you might be surprised, like, how can this be done, right? So we'll be going through that now today. So we'll be talking about an algorithm called GRPO. So GRPO is something. It's an algorithm from DeepSeek team. So they came up with this algorithm, which actually does something. It does reinforcement learning algorithm. So it's called group relative policy optimization. It's mouthful. If you guys don't, I don't want to go too deep into this. I'll just explain how it works. You already know exactly here LLM generates, and then you have a critic that is deciding or judging, right? So and then giving feedback, and the language model improves. So same thing with GRPO. GRPO actually makes the model be more efficient by generating different outputs. So you have a model, you or your AI agent or model. If it is, I might talk interchangeably a model or an AI agent. It will apply for both of them. The same algorithm works either for a model or even for a AI agent. In terms of a model, it is a language generation. In terms of an agent, it could be an orchestration of tool actions that it has to do to make it itself better, right? Those are two different ways. So if I say model, please don't get confused. I could use them interchangeably. This algorithm could be applied either to a model or to an AI agent. So here, what's happening is this algorithm will actually make the model or AI agent learn a skill. They are able to use GRPO to make the model reason. That is how DeepSeek is able to reason really well because of this algorithm. This algorithm is way compute efficient. There are existing algorithms. It's not that DeepSeek came up with a novel algorithm altogether. There's something called DPO, PPO and DPO. These are two different algorithms that are already existing now, which OpenAI already used to make their models better or align or post-training their model. They use these as their RL algorithm to align the model to generate, in the post-training to teach them how to generate human language with human feedback. They're able to use it, but these are very expensive. The reason why they're expensive is they're compute intensive. You are basically training a huge model here. If you see here, you're basically training a huge model to just give rewards to the output that is generated. In GRPO, that is eliminated. You're just basically using the same model. You're basically seeing the output that is generated, and without any secondary model, you're actually making the model, see which generation is good, and then based on that, what you're doing is you're generating multiple responses per query. So almost like you're asking a model like ChatGPT to generate like 10 responses to your question. You say, okay, can you tell me a great joke? Now it generates 10 jokes. And what you do is, out of 10 jokes, you see which is the better joke, right? And you see, score each joke. You see which is good, which is have a proper format, which is actually makes you laugh. And then what you do is you subtract mean and divide. It's a bit of math that you do here. So I don't want to go too deep into this, but it's mainly what they're doing, trying to see is they're trying to see which one is doing really good in all of this, which response is better, and based on that, you are able to just group. The reason with group relative, that's where the name that says group relative. Policy optimization is relative to each and every joke. They see how one joke is different. How one joke, if one joke is really bad, maybe out of 10 jokes, five or six jokes are not that great, but four are really good. Then it uses that four trajectories. It analyzes what are the different ways how the model produced them. It subtracts that mean and just does some math and goes back and based on the trajectories that gave better jokes, it goes back and fine tunes the model so that it keeps on generating better jokes eventually. So it just tries multiple generations, now goes back and fine tunes the model based on the best joke that the model thinks is good. So it's actually using a different LLM there. Yeah, good.
So basically, is it like similar when we ask ChatGPT about some kind of query? It sometimes give us two responses, and then it
Yeah.
says like which response is good, and
Yeah,
we
they kind
choose
of
one. Hmm?
Yeah, they're kind of doing the same thing in the backend, but I think they're mainly doing that in your user level. Like they're primarily doing that to see which one is better, like which one you recommend. They do sometimes, yeah, I do see that sometimes. They say, hey, there are two responses, tell me which one you like. So they're kind of doing the same thing. They might be creating a LoRa for you on their end, which is saying like, oh, maybe the user like this response a bit. So they do it very sporadically. They don't do it every time, right?
Yeah.
They do sometimes they ask. Yeah, that is because to align the model to your preferences. So
So
that
when
is
we are
what they're
talking
doing
about
there.
GRPO, this is something that we are talking about implementing with
Mhm.
LoRa. Or okay.
Yes, yes. This is something that we could do as part of the post training to train the model to do math or to reason, right? You are able to do that here. So we're basically trying to help the model to learn something different, to reason through his problems, to do math. There are a lot of people also using reinforcement learning where you can have a model just do mathematics in his latent space, that do in a proper match. So you're truly teaching the model to do math rather than getting stuck with that, the because previously it was just mimicking what it has learned as part of his post training, where you give so many examples trying to mimic that examples, right? But now with this process, you're truly making the model to do math. You're truly making the model to learn a game. So that is what you're trying to do here. So you're trying to get these behaviors which the models inherently lack, even after supervised fine tuning. The supervised fine tuning process is just you're telling, hey, mimic this, be a chatbot. That is what you need to do, and you're just mimicking that, and then it is just producing that. That is also the root cause of hallucinations, because it just uh but you ask it strawberry, how many R's in strawberry, then the reason why it says that is because it doesn't do any reasoning, it doesn't analyze to the problem, it just based on its training program, based on the way we train it, the model, the tokenization, all of these processes actually make the model a bit dumber, in the sense that they don't truly answer a question by thinking, they're just producing it by mimicking the training data. So that's what it's saying. But with GRPO and with RL, you are basically changing that. You're making the model truly generate a response, and then come back to this. So hopefully that answers your question. Um, I don't know who's this. Mo? Mo, I think I see some a lot of marks that you're making on this. Uh, is it okay, Mo? I think there's something going on. Maybe you're just doing some. Okay. So basically, in this, what you do is uh, you're basically doing a warm start with high quality data. So there's a supervised fine tuning initially. Once that is done, next comes your reinforcement learning with GRPO. So what you're doing is you're inserting reasoning phrases aligned with feedback. So you give this. I think there's some mistake here in terms of okay, yeah. So what it's doing is you're basically inserting a lot of reasoning phrases. You're having the model. In our, let's say if a model doesn't reason, so how are you making the reasoning proper? So you're telling, okay, given a problem, just generate 10 different reasoning steps for this. It generates reasoning, but you're going with the reasoning which actually does true reasoning, which just break the problems even more granular to think through the problem, right? So, and then based on that, you're basically trying to align the model back into it. So you're basically, it could either be using synthetic data that you generate and filter synthetic data. You're generating and filtering synthetic data is nothing but you're actually making the model to generate some outputs, different kinds of outputs, and now you're just grouping them output, which is better out of 10. Okay, if 5 are better, then you're just making the policy change to generate those trajectories a lot more than, and then penalizing the model to not generate the trajectories which are not yielding better jokes from your model. So that's what you're doing here with GRPO. We will see this in action now pretty soon. Like we'll be training a model to do tic-tac-toe, to learn tic-tac-toe game, because most of the models inherently cannot play that. We're not having the model uh, play that game, we're just teaching that game to the model. So how can we do this, right? GRPO and all of them. I know this all sounds really researchy and different, but how can a developer do this, right? I mean, that is where this art comes into picture. So it's from OpenPipe. I think they are the ones who created this. It's an agent reinforcement trainer. So it's an open source reinforcement learning framework that can train multi-step agents using gRPO. So if an agent requires different kind of interactions to perform a specific action, you are using this library, and it will have your LLM align with all this. So what you're doing is you're improving agent reliability by allowing LLMs to learn from experience. So you're integrating RL into this Python, any Python application, and you're basically doing on-the-job training. So they call it on-the-job training is because now you have your model or your agent already working in your production. You get different traces already from your agent. You can have for every action, you might ask your agent to produce like different series of actions to take. Maybe it was travel ticket booking agent. You might say, okay, just go and act on it. Maybe do like 10 different actions. Out of 10 different actions, maybe 3 or 4 are failing because of different hallucinations. Now you are telling the model, okay, out of 10, 5 are failing, but 5 are really working well. So now you create a LoRa that can basically produce those trajectories. So you're basically back propagating from that and creating a LoRa that can actually improve itself and make the model better at producing successful trajectories. So you're reducing the trajectories which are negating, and you can probably make the model better and better on the job. So that's what the on the job training actually means, because you're having the model generate different trajectories and then only iteratively making considering successful trajectories and then making the model better at it. So.
I recall what I understood
Mhm,
from here.
mhm,
So basically, art is kind of a library. I forgot what it stands for. So
mhm,
art basically is a library that helps to utilize GRPO, which is
mhm,
like a reinforcement learning
mhm,
model to not model or a way to um, fine tune or post tune the LLMs. And
mhm.
how it works is basically maybe the art is giving all these kind of these different kind of trajectory. Who is producing those trajectories?
See, GRPO, right? GRPO works that way. So it generates multiple responses per query, isn't it?
Okay, okay,
And each is code. Each trajectory is code for accuracy format. And then comes the advantage is what trajectories are producing successful ones. And based on that, you're updating the policy, which is your model weights or LoRa that's happening.
okay.
Does it make sense? So here, this is how GRPO algorithm works, but art is basically abstracting that complexity from your code. If you have your AI agent code already, you don't have to deal with GRPO. You don't have to build GRPO. All you're doing with art is nothing but agent reinforcement trainer. Agent reinforcement trainer. That is what art means. So it's just an abbreviation that they created. So what they're telling is, hey, you know what? You're a developer, you're a software engineer. You don't have to deal with all this. Just use our library. We have our own backend in the cloud. You want to do GRPO in the cloud, you could do that. Or you want to have your own model on your own GPUs, you could do that. But what we're doing is GRPO under the hood. What they're doing is, okay, for every question that a user asks, maybe you have an AI agent that is doing coding, right? So this coding agent is actually giving the output to your user, but maybe there are 10 users. Maybe now instead of giving one output, you have your agent produce 10 output. You're not streaming all the outputs to your user though, but you're just creating that behind the scenes. And out of 10, you again evaluate which one are really the better output, which one is production ready, which one doesn't have bugs, which one is using proper packages. Now you know those trajectories. Now what you do is, now what's happening under the hood is it's just computing those rewards, it's calculating which is better, which are the better trajectories, and then updating the policy. So that is what updating the policies again, creating a LoRa for that. So these are all happening here. So this entire thing is happening and behind the scenes. So now your application doesn't have to do all of it. Your application eventually will get better because now you're creating a LoRa that actually making your model generate better code, right? So that is what you're doing. It's almost like online evaluations that you're doing, but it's not just evaluating the output. You're actually training the model to be better and better as it's generating more output, as it's getting as many queries as possible in the real world. So that's what's happening with the real world task here. And so it's just a library, so you don't have to deal with all the GRPO and everything like that. It's just happening in the cloud, and this package itself is taking care of that. You just have to pass some variables. What should be the learning rate? maybe how many trajectories or how many times it has to go ahead and learn this tool, right? All this or learn a game. You are basically defining them with this library. You're just passing them as variables, and that's all happening behind the scenes.
So we need
Um,
to choose any kind of base model for this one as well
Yes, yes, we do because without that you can't because that is what you need a base model. When I say base model, you
with
could
the
use
weights.
a with the weights, yeah, base model with the weights, but I'm not talking about a model that is pre-trained. I mean, it could should certainly be a post-trained model which already knows how to respond back. Maybe, depending on the task, right? Maybe you're making the model generate English, then the post-training process will actually make the model fine-tune or at least do instruction tuning, right? It just can speak English, post-training model. It could be any post-trained model, but you're again fine-tuning it or using reinforcement learning to make it better. So that is what
Does
you're
it
trying to
make
do
any
here.
difference if even if it is a pre-train or post-train, we will have like
It
the model?
does, it does, it does. You know why? Because pre-training model are really terrible. At least they should be
Oh,
aligned to know to generate English. Pre-training models cannot even generate English. If you ask a pre-train, you just go and on a pre-training model, they just go generate like gibberish. It might generate a bit of English and then it might generate math in between.
okay.
So that's the problem with the pre-trained model. The reason why I said, hey, you can use a base model and do this is because when I'm talking about maybe you want to build a scientific research model, or maybe you want to build a model to generate chemical components or metallurgy or invent something new, then you start with a base model because it has world knowledge. It does know what is a chemical, how in H2O, what does H2O mean? I mean, it kind of knows what comes after that, but it does but still it is not completely aligned to human preference, right? But in our case, all this model that we are interacting with, they're all chat template models, so they are actually fine-tuned with saying that you are a chatbot. So whenever you ask a question, you're basically interacting with a chat model because they're post-trained with that lot of examples of chat interface, like back and forth questions, right? So even in this case, that's what I'm saying. I mean, most of these models that we work with now, those are all post-trained models. You can start with the base model, but you might have to invest significant amount of time to at least make them align towards human preferences. So you have to, that will be a huge undertaking. So most of the model, you will find a lot of post-trained models already, right? We are going to use Quen model today to do this post-training. I'm sorry, to do the GRPO. Will that make sense? Any questions? Sanjan, have your hand raised.
Hey Raj,
Yeah.
quick question. So art is for multi-step agents from what I read. And for
Hmm.
multi-step agents that have access to tools that can carry out right actions, do you need
Hmm.
to make simulated environments so that you can test it and then choose your appropriate path?
Yes, you could do that. That's you could also do that. In that case, you don't have to have it in a live environment. You could actually create a simulated environment, maybe a browser, or maybe an API that you want to just test it out. And yeah, you could just have your model do the same thing, even in the simulation as
Got
well.
it. All right. Thanks.
Yeah. Yes. So you don't have to do it in production. The reason why I put it is on the job training is, if you already have something ready and working in your training, you could still tap into this part of the GRPO so that you can have the model. Because the reason is when you ask real questions, there could be real incidents that some agent would probably work on. Maybe, a refund, right? Oh, customer chatbot is great, but how do you deal with a refund? Maybe someone is asking for a refund. You have to do as different types of things. There's different types of flow that goes in there, right? Maybe you have to get some input from your from your Salesforce side, and something from your CRM, or from something from your NetSuite to do that refund. So it has to know this complex interactions of different API calls that it has to do to give you an output, right? That's something that you would able to do that in a real setting, so that the agent can learn a bit more in the real setting. But still, simulator is great. You could still use simulated so that agent can be deployed in production after this RL fine tuning is already done. So that makes sense. Um, so if you guys have any other question, I think we can discuss that after this. It's just a simple why art is just plug and play. I mean, they already have wrappers. You don't have to learn RL. It just you just have a plug and play integration. You have train anywhere. You could do the training locally. You could also do it on a GPU. Today we're going to do that on a Google Colab. It doesn't require a lot of compute. Observability is inbuilt. I mean, yeah, you can integrate that with LangFuse or weights and biases or OpenPipe. And then you can train different parameters, and in order to make it, in order to have these parameters for the training to run. Yeah, so installation is pretty straightforward. This is the architecture. They have a client. Client is nothing but any code that you already have. That could be a client, maybe an agentic code. Rollouts are something that different trajectories. Rollouts are different times that you are trying to capture that. Like maybe 10 times. How many times you want to have the model do that? Maybe play a game, or maybe go out and do multi-agent interactions and then compute rewards. So that's what a client would do. And server is what it's handling all the inference and training. So inference reason is because now you're having the model generate different outputs. So that means the model should able to have an inference engine, and it has able to do that inference. Inference is nothing but the output. I don't know if anyone of you in the call doesn't know what is an inference. Inference is nothing but something that generating an output is nothing but it's performing an inference. It's just generating you an output. It is not training. Training is different than inference. So training is when it already learns, and inference is when it answers questions, user questions. So here, it handles all the inference and training, because GRPO, you already know GRPO. This is how GRPO works. It has to generate multiple responses per query. A query here could be any user question that someone has, or maybe it could also be a query, a question an agent has to go and perform a task, right? That could also be a query. So what it does is run agent, it generates different trajectories, right? And then it score assign reward for all of these scores. It does scoring for different trajectories. It batches, so it groups all the episodes which are successful with that we need. And then it trains, it optimizes this training process via GRPO, and then you deploy that LoRa. So that LoRa is, so when I say LoRa, it's called low rank adapter. So when you want to fine tune or change the model weights, usually model weights are nothing but blob of numbers, huge matrices that are actually, that is what producing an output, by the way. When you ask a question to ChatGPT, when it's producing an output, it's actually going through a lot of computation to give you one answer, like one token or one word. So, when you want to change the model policy, so when you see here, based on the feedback in these diagrams, when I say it has to go ahead and fine tune this, or learning group and update, this update is nothing but your model has to be updated. But if your model is so huge, you have to have a lot of computation to update the model. So you're basically introducing a really small weights and updating only those weights. So you're basically fine-tuning the model, but you're not fine-tuning all of the huge matrices, because some model have billions of parameters. You're just introducing few millions of parameters and updating those. So that way you're basically making the model learn that behavior with LoRa. So that is what a LoRa is. And I could go more deeper into LoRa, but if you really need some help, I can give you some resources to learn LoRa. But yeah, just remember that's a way to fine tune a model, to change the behavior of a model by introducing new weights. So yeah, integrations, yeah, it supports a lot of models. It has VLLM integration, and it also has weights and bias. Weights and bias is just an observability tool. So when you're doing this training process, you have to see all the observability of how the training is going. You could probably use these tools. So example tasks, they already have some notebooks which I can share. Today we're going to see this tic-tac-toe notebook. I think it's basically a simple 7 billion parameter model. The behavior, it's basically surpassing the performance of GPT-4o model at the classic game. So it can play better tic-tac-toe than GPT-4o model. So that's it. That's a great achievement. How they're able to do that using GRPO and fine tuning. If you see the email search, it's able to use even at 14 billion learns to search emails using retrieval agent. 2048 is a game, which I'm honestly, I don't know what game is it. I never played it. But yeah, if any one of you already know that, it is actually the Squint at 3B or 7B actually was able to master that puzzle game through multi-turn play. So these are some notebooks that are already available, which I can share you now, some website that have these all available. Let me share that notebooks with you guys. And today we are going to see a notebook, which is, yeah, hopefully you all can see my screen here. Okay, I think you can see the screen already, the art screen, which I'm showing here. Yeah, OpenPipe. Yeah, these are all the notebooks. You can see different performance that they have put here. Today we're going to see this agent. I will probably share you a a new block. Okay. Yeah. So let's go ahead and start with this notebook. I mean, I will share this notebook link in the chat. You all can just try with this. With a lot of chats, let me go ahead. Maybe okay, I do see a lot of chat here. I think we already crossed an hour mark. So let me just go ahead and see a bit of this chat and then come back and we can run this. If anyone of you go ahead and run this, you can run it. It's very simple, straightforward. But make sure that when you're running this in your GP, I mean, in your Google account, first thing is you should make sure you have a Google account. So make sure that you have a Google account because Google Colab provides this GPUs for free. Make sure that in the runtime, you need to change that runtime to T for GPU. If sometimes it might default to CPU, so just make sure that you use this. Okay, there's a lot of things here. Okay, tuning is possible if model. So Sam asked me this question. Tuning is possible if model is open, right? In other words, ChatGPT cannot be fine-tuned by us by. No, we can also fine-tune ChatGPT. ChatGPT provides you ability to fine-tune their models. You just have to go into their developer portal and fine-tune. You just have to provide your data and you can fine-tune it. The thing is, you might not have access to the model weights, but they do it on your behalf, Sam. So Julian asked, what is RL again? It's reinforcement learning. Julian. Sounds like we need a statistic degree to give out RGRPO rewards. I mean, yeah, I don't think we need statistics degree. Anyone can learn GRPO or even the statistics behind it by using ChatGPT. So I think if you really want me to, I can create a new session on that if you really want me to present more in detailed math. But I know given our who all are actually in this call, I don't think a lot of them are actually from technical background and also math is if I just show math, I don't think anyone would even be in this call. They might leave early. So if you are really interested, I can give you some articles on giving you a detailed explanation, a simple explanation of GRPO with simple math. Okay, no problem, Mo. Can we tell Art that we want to use LoRa versus other tools or competing models? I didn't understand your question, Sam. Can we tell Art that we want to? Okay, can we instruct Art that we want to use versus other tools or competing methods? We could, but do you know other computing methods other than LoRa? Maybe something like
LoRa or other type um
sorry?
LoRa or other type of
Oh yeah. I mean, yeah, that's also a LoRa, right? LoRa, that's fine. But when you're doing LoRa, then you're basically doing a
so
quantized
maybe
LoRa,
the
right?
question is like, can we specify which one we want to use?
I think LoRa's are the best ways to do this fine tuning. Other than that, is full fine tuning, and there's also prompting. So I don't know if there could be some research papers out there which are actually doing prompting to maybe using reinforcement learning, but I don't know how that behaves because there's also a recent paper by MIT MIT or someone that just came out. They call it ACT, agentic context learning. They use something similar, but they have a model do that context engineering all by itself to make it better domain tuned. Maybe we could do something like that, but I don't know. Most of them use LoRa's, but we can still discuss that. But I don't think they have any other ability. But if you research on that and let me know, that would be great, Sam. But I don't think so as of now. I'm not aware of that. LoRa being a very proven method to fine tune anything. Yeah, no problem, Julian. I mean, if you're not familiar with anything, yeah, there's no wrong in asking. Uh, how sensitive are to temperature parameters set for inference calls in the agent? Is the GRPO optimal model tied to the temperature parameter? Obviously, temperature is something that your LLM tied down to, and in terms of your LLM, in terms of inference in the agent, definitely it's all the foundation, right? When you're tweaking your foundation's parameters, then your agent's behavior might change. based on what you're using it for. If you're using it for tool calling, I don't think tool calling would actually change. I mean, it might change temperature, but at least you always need to tweak the temperatures to find out which is the better fit for your model. Is the GRPO optimized model tied to the temperature parameter? Maybe to some extent, but because obviously, because GRPO is, in the end of the day, it's relying on a lot of trajectories which are provided by the model itself. So it's actually inference itself. So if the temperature is changed, then GRPO doesn't produce trajectories which might not be really efficient, or it might be great, it might be really be efficient or not. We don't know, but still that is sensitive to that inference, right? So GRPO is also dependent on inference trajectories. So when you change your temperature parameter, GRPO should also have some impact. So yeah, definitely, temperature does have GRPO is sensitive towards temperature settings for your model.
Thanks. Yeah, I was just thinking about the sort of sampling of the different trajectories.
Yes, yes, it does. Who would nine? Julian, I mean, you can connect to me on my page. I mean, you can connect to us on LinkedIn. We can discuss a bit more about this. How to use Collab, please in brief. Yeah, sure, I mean, did you open this Collab in here? If you open Collab, you should probably see this notebook. Do you see it? You can just reply by saying yes or no, and then I'll let you know. I'll guide you through this process, how to use Collab. Okay, so after you did the Collab, all you have to do is, first thing is you can do is, you can just come here and click Run All, and Run All will probably run all of the cells, right? And you can see the output. Or if you want to run step by step, you could still do that step by step. But I usually do Run All, because when you're doing step by step, sometimes there will be steps that you might miss and your cells would not run. So I usually do Run All, which will actually running all of them sequentially. So let me know if you can't run this. If you get any errors, please let us know here. Yeah, Rose. I mean, that's great. You want to learn the math. Definitely, I'll present that, because if I add math here, it might take a while. That's the reason why I didn't do that. But it's just very simple math. GRPO math is not. It's just you're averaging. You're just. But who is giving you which is better? It's again an LLM telling you this response is better, and you're just creating average, just a moving average of different trajectories. So it's as simple as that. That's the reason why they're calculating a mean and then looking for the reason how you find something is better is based on scoring, right? You have an LLM tell, okay, which is a better score, and you tell, okay, what score you give. You give it a 5 score, 2 score, 1 score, and let's say if LLM says, okay, out of 10 jokes that it gave, maybe 5 jokes I give 4 as my score, then you're using that trajectories which got higher score, and you're rejecting all the trajectories which have lower score, and then you're improving the model based on that. As simple as that. But there might be an equation for that, which I can provide you with. But it's just relying on an LLM to do that scoring. I can share you a GRPO notebook that can explain you that a bit more detail, but it is very simple and it's a very smart way of doing this, because DeepSeek team, they don't have a lot of compute, but they're able to produce better results because of the algorithm innovation. They created this algorithm to make it a bit better. Okay, so now that we answered all the questions, let's go on to the installation process or running through this Collab notebook. So what we're doing here is, first thing is we are actually having this model. First thing what we're doing is we're just initiating all of the environment. We're setting up the Collab. We're looking for this GPU because it runs with Tesla T-Force. And then we're also installing VLLM, because VLLM is an inference engine. So in order to run a model, the model should be ran on some engine to do the inferencing. So that is what VLLM is. I mean, I don't know if any one of you have attended my previous sessions. We did a session on VLLM last month. It was very extensive. If you really want to learn VLLM, it's on my YouTube. You can always go back to that previous session that we did, and you can review how it works. But yeah, VLLM is an inference engine that runs the model. It's like an engine that runs your models. And Triton is a kernel that you might use here to create, to use this CUDA backend. And then you have OpenPipe. This is the model, the package that we're going to use to do the GRPO. And these are other models that we might need here. Here we're setting up environment variables. These environment variables are set for observability, which we are not doing now. I don't think we need that yet. But if you really need it, you can create an API key in weights and bias, which is a website. You can go there. They call themselves weights and bias. I don't use this. We use this is the platform that you can use to create a you log in and you can just create a you create an API key and then put that here, which if you really want to do it, you could do that. But as of now, we're not doing that in this article since we don't use weights and biases. Okay, so what we're doing now, right? See, once we know that GRPO or reinforcement learning requires an environment, right? And here we are having the model. So this environment is something where the model goes out and acts on that environment, right? So what is an environment here in our case? So what we're teaching the model to play tic-tac-toe. I don't know how many of you know tic-tac-toe, but I really love that game. Tic-tac-toe is a very simple game. So I don't want to teach that game, but at least I want to show that how it looks like. So this is what the game is. Like you can just, this is X. The computers. There's only two moves, X and 0. Computers. It has 0 move, and I can have X is my move. So I come here. I do X again. Okay. I think I might I think I might lose this game now. So so if you see when you lose a game is if you put something like, let's say if I come here, I put this, so the model is not 1. If in case I put up X here, if there's a similar thing in a row or diagonally, they won, right? So so as of now, I created this, and next I would create this, and I would do this. So game over, no one won. So it's a draw. So basically, if something is done like, if you see all zeros come in a diagonal, then they win. Or if you could put X in a vertical way or horizontal way, it's the same letters, then you win. So that's the game. So we are trying to make our AI or our LLM to learn that game. To play that game and learn that game. So how are we going to do that? So we are going to first model that environment. So what is an environment? So now the environment is the game itself. So we need to create that game programmatically. So what we're doing here is to create that game programmatically. We create, tic-tac-toe game. We create all these data types, dictionaries that might hold the board. The board is the board that we have seen here with all of these different values, and then you have an agent symbol, which is X and 0 are two different symbols that anyone could have. An opponent symbol is something you can either choose from X or 0, and then you have a generate game. So this entire thing is just a programmatical way of creating this environment where an agent can apply a move, and then an opponent can apply a move. So we're basically modeling that programmatically here. And you're also checking how to check for a winner. You're also checking if there are some moves which are going beyond something, so it's invalid. So you cannot do that. So there's an invalid move as well. So you're just basically making sure that this programmatically creates this environment where you have valid moves, where you have how an agent could move or an opponent could move, and what are the acceptable values. So you're basically modeling the whole game here and the environment itself here. So what happens after this is now. So now we have the environment. Now our agent should go ahead and play this to try different trajectories and see how well it performs over time. So you have you're basically creating a model here. So what you're doing is you're basically using a local backend. So as previously we have seen, Art will support local backends or even cloud backends. So local is when you're using your local GPUs. In our case, when you're using Collab, we're using our own local GPUs. That is, we're setting our runtime to be, a T4 GPU. So it's using the local GPU. We're going to do GRPO on this notebook itself. But you will still use cloud if in case you want to use that. And you're setting it up, what backend that you want to use, and then comes creating a model. So you're basically creating different rules. You're creating a base model that you want to use to play this game. So you're using Qwen 2.53 billion instruct model. So if you see, this is not a base model; it's an instruct model. It's already fine-tuned with instructions, so it can follow instructions. Because now, in order for my model to go out and play this game, I should be able to provide it with an instruction, isn't it? I should be able to prompt it. Otherwise, it will not follow my prompt. So that is what we're trying to do here. So we're using an instruct model, which is a Quen 3 billion parameter model. It's very lightweight. And it can run in the GPU. And this is the base model that we're going to use to make it learn tic-tac-toe game. And what we're doing is, if you see here is the model that we'll be training a LoRa on top of. So we are basically using a LoRa on top of this model. So this is a small parameter model that we might introduce later on, LoRa's that we might introduce on this model. So now what we do is defining a rollout. So what is a rollout? A rollout is a single episode of an agent performing its task. So it's just one episode, means it's just one game that plays. So it generates one or more trajectories, which are a list of messages and choices. In this example, the rollout function generates a game of tic-tac-toe. So that's what it is doing. It's just basically generating that game, and the agent plays it until the game is finished. It then returns a trajectory which contains all the system and user messages presented to the agent, as well all the choices that the agent made. So it's basically getting all of the system messages, all of the back and forth messages that happen between the system and the user while playing the games, and it's just returning all the choices back to the model to be back propagated and to train the model on RL. So these are different trajectories that they need to be trained on, right? So when the game is finished, the reward for the agent's performance is calculated. And then if the game is won, lost, drew, yeah, you know exactly what the reward is. So GRPO really works well in self-verifiable domains, right? What is self-verifiable domain? So when you know the output is right or wrong, it is self-verification, right? So you don't need an external force there. You don't need something external to tell if that is right or wrong. Because math, if you're trying to solve a math problem, you know exactly after generating math, maybe 100,000 times, maybe you might generate a right solution. And now you know exactly how to come to that right solution, because math is a self-verifiable domain, because it just verifies if you solve it, you solve it. Generating a joke, is it self-verifiable? I don't think so, because generating a joke, you don't know, you generate 100,000 jokes, still don't know unless there's an external model telling which is better joke. It's not self-verifiable, right? Something has to come in and tell, okay, this is nice joke, this is bad joke, or maybe a human telling which is a better joke. Games are self-verifiable spaces, because now you know which is one or not one. You play 100,000 times. Now, if you won a game, you know that's it. You got a reward. Now you go back prop and then make yourself better. You have this action and you know what the reward is. The reward is winning the game. You know what the reward in terms of generating math problems or solving a math problem, the reward is you solve the problem. It's self-verifiable, isn't it? So that's what we're doing here. So since we're playing a game here, so the game is finished, reward for the agent performance calculated, and then if you know whether the agent won, lost, drew, or errored. So these are all different trajectories that you find, and this is what a rollout function would do. So you are basically calling this rollout function multiple times in parallel during the training loop. And this is the code for that. And you will see here in the code how you are able to create these trajectories, and also you're able to create a system and the prompt here where you're telling you're a tic-tac-toe player, you're playing against an opponent, always choose a move likely to lead to an eventual win, return your move as an XML object, because now when the event is, if the moves are written as an XML object, you have all these trajectories that are auditable trajectories, right? The different moves that actually led to a win. So, and you're just instructing the model to return the output in a certain format so that we can later on use this to, to backprop into the model. So if you're doing a move like this, just return that in this XML. And other optional moves are A1, B3, C2. These are all different ways in which the moves will be calculated and those will be returned back. And this is the metadata for that. And if you see, this is how you're modeling the trajectory, and then you're just having the model, and then you're checking if the game was won or not. So you're basically passing all these trajectories, all these messages into this, and if there is any kind of exceptions that are caught, you're basically catching all of them here, and you're checking for the winner. If the winner is there, then how do you calculate the reward? So the reward is if the agent won, is the trajectory reward is 1. And if the opponent is 1, then the trajectory reward is 0. So the agent lost, so it has given only 0. If there is a draw, then it only gets 0.5 reward. So you're basically modeling the reward function here, how to give rewards based on the different outcomes. If you lose, we give you 0. If you won, we give you a 1. If you win, we give you a 1. So we're just modeling that here.
I have a question here. So
Yeah,
when we
Rahman.
were talking about GRPO, we were
Yes.
saying that like at every stage we will have like multiple trajectories out of which we are going to choose which one is the right trajectory. I mean, out of which we will like kind of filter the most appropriate one. However, like in this situation, what I understand is like the whole game is going to play like at every stage how the like reinforcement learning is like at every stage it will take the steps, and we are like just capturing those steps whichever the step the model is taking, and then at the end if so there will be like one set of trajectory based on which we will get the result, we will we are going to give the rewards. So it's
Mhm.
like at this moment it is like one pair of trajectories, so probably we are going to run this 10 times and then we will have
Yes,
like
yes, that is what I mean. We are, yeah, this happens in the next thing, right? Now we are just preparing the rollout. We're just telling it, okay, you play the game, you win, you get this, right? We're just modeling that rollout process. But in order to scale it to multiple trajectories, that's happening here. So what
okay.
we're doing now is the training loop is where all this happens. So for instance, like now what they're doing is they're creating 100 steps. The rollout function will be called 200 times in parallel. So there are 200 games which are played in parallel,
Makes
right?
sense. Yes,
So
thank you.
now each game will produce a trajectory, which will be used to update the model. So the gather step will await for all the trajectories to be generated, then it will be deleted all, then, once the reset check mark and train the new trajectory. So you're basically doing the same thing. So yeah, now it should make sense for you because that was your question. And this is where you see how we can scale it up, right? And create all these trajectories. And we're doing 200 of those. So we definitely get a lot of good trajectories that might be beneficial for us. And you see that here you are defining the training steps, you have the rollout per step, and also you are defining a learning rate. These are all something that you define because now you're using these parameters to train your back propagating, you're training your LoRa. So you basically do that here with these parameters, which will help you to look for how basically you're trying to define your training configuration. And then you're using the model. Now what happens is this is where all of the so now now comes after here once the LoRa is trained and it's actually loaded. It's happening under the hood. All of these LoRa everything creation, there's a bit of abstraction that they have given here, but what's going on here is once you have that, you update them, you use the model, so the model that is trained and it also has a LoRa loaded. You could see that in here. You are actually loading that in 4-bit. You have the LoRa model that has been loaded into this main model checkpoint. You can see the checkpoint has been loaded here, the LoRa model path, and then now you're again having this persona saying that you're a tic-tac-toe player, but now you have the LoRa loaded, and then you're just generating the model to go ahead and play some games, and you see the model is able to play some games here. So.
One question is like when you were doing the training, so when we were during the training, we are defining like that 48 number. So basically, that is the like most best like 48 best trajectories. Are they like the I mean, at the time of the training, the parameters that we were setting at the time of the training?
Yes.
Yeah, this one.
Yes.
48. Yeah. So the
Rollouts
rollout
per
per
steps.
step. Yeah. So
Yes.
are these okay? Okay. And then at what place are we like updating? I mean, at what
Hmm.
place are we training? And are we actually training the model, like updating the parameters? Is it like done behind the scene?
Yeah, it's happening right here. You see this, right? Here you see this. You're defining the training here. Your training steps are 2 steps. You're doing rollouts per step is 48. You're also defining a learning rate. And here you are basically using this art module to gather all the trajectory groups. And you're using this tic-tac-toe scenario and you're using different steps. So you're doing one or as we define the 2 steps for this, and rollouts per step, you're using 48. And then you're basically trying to go ahead and use the checkpoint after this training process. And that's all happening under the hood. That's all happening, that entire thing under the hood. And you can see that here, how that's able to do that. The training is happening here, 4 on 4. There's a loss, policy loss. There's an entropy that is defined. There's a gradient normalization. All of these are defined right here. And based on that, you see there's a train and gather. So gather is where it's actually gathering all of the, if you see here, right here. I'm sorry, the gather should actually be here. Yeah, gather is it actually wait for all the trajectories to be generated, then it will delete all, and but the most recent checkpoint and train the model on the new trajectory. So it's basically defining this to clear out the previous trajectories and only get the trajectories which are actually successful. And then it's basically doing that. So at this point of time, it's actually blocking all the inference, so it doesn't have to go ahead and play the game. Rather, it's just going and doing the training process. So that's all happening under the hood using this art. So all the complexity of GRPO, which I was telling about, that's all taken care of by art under the hood. Only thing what you have to pass is these parameters, these variables. Hopefully that makes sense to you.
Yeah, some
Yeah.
level it is a little bit
Yes.
complex, but yeah,
Yeah,
thank you.
I mean, yeah, they did abstract a lot of this complexity, so that should be there shouldn't be a problem. But yeah, if you really want to have any questions, yeah, definitely reach out to me. We can I can discuss more in detail about that. But using the model, yeah, once that is done, you have the model be trained, and now you could see you are just having the model go ahead and play tic-tac-toe, and you see the model is playing tic-tac-toe here. Yeah, the model lost the game, but we didn't train the model to win the game. What we're trying to do is to have the model learn the game, so that when it learns the game, it is not doing some moves which are very incorrect, right? It actually knows that it has to do proper moves. It has actually aligned itself to play the game properly, rather than and then that's what's going on here. So you could go through this thing and let me know if you have any questions. There are also other notebooks that you can review. And if needed, I'll also share some notebooks on GRPO itself, like how you can use that to. So there is one notebook I really like. Uh, it's from. Okay, I don't know if I opened the same thing again. Okay, so it's from Onslaught. GRPO, Quen model, reasoning. Yeah. So this is one of the notebooks that I really like. It's called it's from, you can actually use Phi or even use Quinn, but yeah, these are all GRPO reasoning reinforcement learning, where they actually have the model do it does learn different skills using reinforcement learning using GRPO. So if you want to get deeper into this, just go through this notebooks. Rahman, I think it will be useful for you. So and yeah. Uh,
Sure, I will. Thank you so much.
yeah, and also yes. Okay then, sounds great. If you any other questions anyone has, we can discuss about your questions. I don't think any other things are here to define anyone. We still have like 25 more minutes, so if you want to discuss, we can.
I have a quick question.
Yes.
It's coming from a non-technical. How
No
much
problem.
Python do you have to know to be able to interact with Colab?
Colab is just existing Python. Like you don't have to know. I mean, yeah, you definitely have to know Python, but the beauty of Colab is it does have everything already done for you. So you could just go click buttons here and you would see the code executing. So you don't have to install anything on your local machine. So that gives you an ability, it lowers the barrier to entry to execute code, but it doesn't give you still need to know how to configure Python in your local machine. But at least it's a good start for you to just go out and play around with this, because now you go ahead and click this button, it will just go and start training, sorry, it goes and execute this code and you get an output. But if you want to learn what is this, you can just go ahead and use ChatGPT, or if you really want to, I think I have a paid version of this. It can actually answer questions in there. Let me show you that. It can answer questions within that specific. don't know if this is the right Chrome I have. Let me. Yeah, but how much Python? I can say, yeah, you basically you need to know Python. So if you really want to execute collab, I don't think you need a lot of Python. It's just about clicking buttons. But in order to understand that, yeah, you may need to know some fundamentals of Python, like how to define dictionaries, how do you deal with different data types, all of those. But with AI, I think it should not be a huge thing for you because I think if you embrace AI and ask different questions to AI and have it explain you stuff, I think it should be fairly simple.
Thank you. Because I'm thinking I can just go in there and since some of the things are there's a dictionary with it, I can just click around, get used to all of the things, and it's actually answer questions. I'm thinking I'll just have to play with it. But thank you.
Yes. But there are a lot of dictionaries out that you can help you, and you can even ask ChatGPT to just explain you code if needed. Like hey, can you explain me this? It will probably explain you all of this part of code really well and take you from being non-technical to technical probably really fast because that's the beauty of AI. It can lower the barrier for entry into any domain really fast. It's just about being curious and being consistent. I think it's one of the areas where you don't have to have lot of you don't need to go and spend years in college to learn something. It could be any skill that you want to learn. You should know exactly what to prompt and learn it. Yeah, Danbo, go ahead.
Hi, Raj. First, thank you for putting this together. I have a question is, the first question is kind of dumb. I knew,
No problem.
I think at the training loop, we talk about rollout function will be called 200 times. I think by my understanding of that part of block or notebook, maybe 96 times. I wasn't sure where I missed because I wasn't follow at the very beginning. Because the block for the training loops, if we go back to the collab,
Okay.
first, I think the training, if I understand the art concept, so art is very nicely defined the retry within the previous block. So I think art package within the internal mechanism is tracking the retry, have a mechanism, put everything together. So I wasn't understand the 200. Secondly, I wonder
The
within
rollout,
that
okay.
retry, probably art has a way to tracking the matrix, which is mirror because you do have a learning rate. So I wonder they probably have somewhere mirror the performance of each for each run, right? So maybe somewhere there's a more maybe you have a session like how you figure out the top 10 best performance and then figure out eventually which one they choose, and then we can narrow down for the next round or retry, something like that.
Yes, absolutely. I mean, if you want to look for all those metrics, I think we can use weights and bias that can show those metrics, that learning rates and how the loss function is improving.
Okay.
And in terms of the 200, I feel like the 200 part, the rollout, the number of steps that they are using here, like this means the 200 games will be played at once. The rollout function will be called 200 times. So, but you see here rollouts per step, they're doing 48 per
You
step,
mean
and there are two steps.
96, right? You will be thinking.
Yes, yes. So that's
Okay,
what
cool.
happening here. It's not exactly 200 because see, if you do 200, the only thing is it's also up to the GPU, right? Because we don't have a lot of GPU. We only have we only have a T4. So maybe because of that, that's the move that they've gone with. That there's a reason why they tweak to a lesser thing that at least can train on, that is trainable on.
Got it. Yep.
Yeah, on this GPU. Yeah.
Thanks, Raj. Yep.
Yes. Yeah. Okay. Thanks for correcting me as well. I mean, I think
No,
I
it
should have
wasn't correct. You
understood it.
just
Yeah.
thought I put
But
something.
yeah,
Yeah. Yeah.
But yeah, definitely.
I
That's
just want to give an example. Yeah.
absolutely. Yeah. So yeah, thank you, Nambo. Any other questions anyone has? Okay, so having fine-tuned using R, do you have an example of its use in Tic-Tac-Toe agent that is being chain prompt to use it post-trained capabilities? That it being chain prompt to use its post-trained capabilities.
So yeah, hi.
Yes, Sam.
Raj. So
Yes, Sam, go
just to
ahead.
clarify, yeah, thanks. for answering all the previous questions. So
Sure.
the question is, okay, so you post-train, right?
Yes.
Now the rubber meets the road, so to speak, where the
Yes.
agent is being where the agent can be used. I mean, it's using its post-training capability, correct? Otherwise, what's the agent good for? So you trained it or fine-tuned it, right? Like you showed. Um, so
Yes.
now how does it deploy its post-trained capabilities? That's the question.
Oh, right here in the last
Many,
cell.
yeah.
Yeah, in the last cell, what you're trying to do is you're having this model play tic-tac-toe now. So if you see this last cell, if you execute the last cell in your Google Colab, you would see this. It's having different moves. And this is the agent move, and this is the updated board. And you have the move here, which is of move 3 of the board, and you have the agent move, which is A1, and now it's updated, right? A1 is right here. So, and then you see there are a lot of there are different, there are a lot of invalid and reasoning, because the reason is we haven't gone through all of I mean, I don't think this is a really enough training because based on the compute, but as you keep on scaling up the compute, probably you would also reduce this number of invalid moves. But if you see there are some invalid moves by the agent, but you see this is where it is actually working. It's actually trying to go ahead and play the game in all these 8 moves. But the game was lost. But you also see a lot of noise here because it's going and putting the moves in some places where it's not supposed to. So it's not fully learned the game, but at least did a bit better. It's able to complete the game even after, trying some invalid moves. But as you scale upon these examples, as you scale upon the number of rollouts, there would be a point where the game it would have been expert. It's all about how much compute we have. And with the compute that we have now, it's able to at least get here. If it was just a raw model without this, maybe you would have seen a lot of these invalid moves and everything. So it would not have learned even a bit of game as well. So that's also, and maybe if you have given the same exercise to a GPT-4o model, yeah, maybe it was not also doing that great as well. Let me show you those performance. I think they have already created those here. You see the tattoo game. They have this loss curve right here. They have these certain benchmarks that they are defining on how games have won. You see with reinforcement learning, 81%, and these are all baseline, which doesn't have any reinforcement learning in place.
Okay. Yeah, thanks for this. Actually, this is what I was looking for because that's the
Yeah.
whole point of a training, right? It's got to win more than it
Yes.
loses.
Yes. Yeah, end of the day, right? It's all depending on like how much compute we have. Probably they might have tried a bit more. They might have tried a lot of different steps and maybe really roll out 200 rollouts, and probably that improved the model performance. But in our case, the only thing what we could show now with the limited compute we have is, okay, just learn some games. And also, whole purpose of this collab is for us to understand the GRPO technique and also look at this. So yeah, but I can share you this. This will be a great way for you to visualize this benchmarking and all, how it is improving and all. Yeah. Okay, Sam. But yeah, great question. Thank you.
Yeah, thanks.
Any more questions anyone has? We can go through. And anyone is working on agents at all? Like anyone wants to share their experience working with agents or any cool stuff that you're doing in your enterprise? Because no one is working on agents, or maybe anyone working with LLMs at all?
Raj, I just get started learning the MCP server and agent. So I'm still a student. So maybe
Okay.
end of year I can share what I learned and a little bit. Still learning
Okay.
MCP server and a lot of things. But thank you for putting this together.
Sure.
If you have a LinkedIn, I'd like us to connect each other.
Oh yeah, let me do that. Let me share my LinkedIn. But yeah, what you're doing is great. We keep learning MCPs. MCPs are really good ways to glue all these AIs together. Unfortunately, I haven't done any MCP session ever, but probably I'll have to do that pretty soon. MCPs are really good because it's definitely helping a lot of AI agents to connect with each other really fast. And also context, right? Because mainly when you keep on building AI agents and if you want to do some integration,
Yeah.
there's only little context that you have. But with MCPs, I think it's really good with dispersing that context a bit between different agents and then isolating
Yeah.
that capabilities. But also look for when you're doing MCPs, also look for how authentication is working in that loop. So I know it might go a bit into deeper
Yeah,
section, but it will be really
that's a very critical part because that's the kind of weak
yes.
link. Raj, by the way, for the inference part, for the art module, do you guys running them through the AWS or running through Azure? And then what are the clouds you more smoothly you prefer using nowadays?
I mean, as of now, we are heavy on AWS. We do
Okay,
use Azure. I mean, we actually use every cloud because we support some clients and we also use our own internal products. We use AWS a lot. We use Kubernetes on all these cloud environments. So whenever we want to deploy anything or move to a different cloud, it's very simple for us to just do a kubectl deploy on that. So yeah, yeah. But as I said, there's so many clouds. Everyone wants to have LLMs to be consumed from them. But when you're doing with AWS, you can't use OpenAI. When you're using Azure, you can't use Anthropic Cloud. I think Azure also provides Anthropic Cloud now, but AWS doesn't work with OpenAI, so they don't provide an easy integration with OpenAI.
you have to do a
So
key
that's
and
it.
all that.
Yeah, we have to get a key from external, and a lot of clients or in some enterprises that we support, they don't like to do that because they have to go through licensing, buying that and everything. So we usually go with Azure a bit. Within our own products that we do, we also use DigitalOcean. DigitalOcean is also a cloud that we use it but for cost because Kubernetes is really cheaper with DigitalOcean. And but most of the other environments that we use AWS, we've been using AWS for a while. So yeah, but it's better if you since you're a student, it's always better for you to either adopt some cloud. Azure, I would recommend Azure because then if you want to apply for any roles, I think if you put that in your resume, Azure with some work on RAG, MCPs, these are really more very sought out of school skills nowadays. But we are not using any art in our production yet. We are not using any reinforcement learning in our productions yet because we don't know. It's a very new thing, right? I mean, also, but we might pretty soon. But as of now, we are not. And
Yeah,
Raj,
we
I
work
have
with
a
a lot of
question.
multiple. Oh
yeah,
yeah.
I can see that because reinforced learning is really great for gaming, but for real case, you have to put a lot of guardrail for it,
Mm.
something like that. Also, first time I saw the Onslaught package, so that's
Mm.
the one you mainly use. It kind of interesting. I think Onslaught. Do I
Onslaught.
pronounce? Yeah. So
Yes,
it's
that's right.
yeah. So that's one you try to integrate a DeepSeek module in the art, and then that's
So Onslaught is basically they do fine tuning really fast and
okay.
well. So Onslaught is they have an algorithm. It's a dynamic GDUFs that they create. So they make different models run on with limited resources. That's the beauty of Onslaught with less accuracy loss. It's
Okay.
an open source package that anyone could use. But you need to go with their own. So you patch all of these transformer modules, all of them. You patch it with their algorithm and you work with them. So that's what Onslaught they do create all
For
these notebooks really.
fine-tuning, save a
Yeah, for
little bit
fine
resource.
tuning.
Okay.
Yes, you can fine tune. I mean, their notebooks are amazing, and that's how I learned GRPO is through their notebooks. So if you see any like it's this 24 billion parameter model, they just fine tune that. And this came out by the way today. I mean, not today. Oh, 23. Okay, it's not a VL. It's a 4 billion, but still, they are very fast at adopting these and releasing their notebooks really fast. So you can see these models, they're all really good notebooks. You can just go play around with them. You can see how they create chat templates, how they're making the model a reason. Now I think they are basically enforcing
Yep.
reason here in this notebook. If you see here, they are basically teaching the model how to reason, and they try it with multiple iterations and just say, hey, this is how you need to do. You need to think and reason, and then reasoning end. They create this format, and then they fine tune it for that formatting.
Very
So
cool.
yeah, you can try
Yeah.
this.
Yeah.
You can
I
try
will learn
this.
that. Thanks, Raj.
No problem. Thank you.
Last, not the least, it's
Okay,
not
go
really
ahead.
a question, it's just we're chatting.
Mhm.
So by your recent experience, for the semantic search, do you have your customer doing project with semantic search? If you do, what are the popular vector database they try to use? Are they using the AWS OpenSearch, or they prefer to use some kind of maybe document DB or something?
I mean, and see, end of the day, this all depends on the environment that they are already with. So there are a lot of environments, because if someone say, let's say, um, AWS, right? AWS already has their own tools, like OpenSearch can provide semantic search. But
Yep.
imagine if the data is already in Snowflake. Snowflake says, hey, we use Cortex. Why don't we use our own vector store, our own semantic search? So we have to go with Snowflake because that decision is easy for us.
Yep.
End of the day, someone has to go, because end of the day in enterprises, like
You
you
have
have so
data
many
in there.
tools.
Yeah,
Yeah, you need to
business
have the
data.
data and also guardrails and also licensing cost and everything. Things takes really a lot
Yep.
of time to move.
We
If it is
do,
a
yeah.
startup, yeah, my startup, like we move really quick. Okay, this is good. I use Superbase for everything, like because that's really easy for me to manage. So we just go use Superbase for all of our apps, even the vector DB is from Superbase. Because it's easy to experiment, move around things, but in an enterprise, no, it doesn't work that way. It's all about like testing and seeing, and if there is Cortex already there, then you just go use that.
Yep.
And also I get really overwhelmed because everyone sells LLMs through different wrappers. Some say, okay, LLM Cortex, Snowflake Cortex. Some say Databricks. Some
Yeah.
say, some come and say, oh, AWS has Bedrock. Why don't you use Bedrock? So there are a lot of different
Yep.
vendors selling LLM tokens, but end of the day, it's better to centralize rather than going with every LLM or every AI product out there. Because end of the day, you're consuming the same token. If you feel like it's easy for you to build your own wrapper and get things really faster, like MCPs, you build your own MCP or you build your own plumbing. So there's build versus buy. Right? Buy will probably it's very expensive. Build is probably not. It's not too expensive, but with coding tools, it's very easy to build anything really fast if you have better developers, right? So
Yep.
yeah, so that's the conflict which I see now. Like everyone, the biggest problem now is the knowledge debt is something really serious in organizations. Is they don't know exactly. They get really fascinated with, oh, this tool does this. It's amazing, but it's just an LLM that's doing all the magic. Under the hood, it's the same LLM, but it's up to you using it or just building something ourselves, right?
Yeah,
That's where
a
I
lot of
see
options, and then
a lot of
things move
options.
fast. Things move fast.
Yes. Someone should understand that space because someone is a decision maker in an enterprise. That's where I see a lot of problems as well. A lot of a lot of money has been spent on the Gen AI projects, and a lot of them are not even successful because a lot of managers or VPs or someone higher up in enterprises, they don't understand AI like completely. They
Well, they
just
know the
don't.
module, the data scientists, they don't know how to integrate them together. If you integrate them, so
Yes.
there's a lot of gap over any, yeah.
Absolutely. I mean, even data scientists, right? Data science, I feel like it's a different, data scientists, there are some data scientists I know they don't work with Gen AI because see, Gen AI is more of a probabilistic machine. They can solve unstructured data. So maybe, summarizing and all, but
Yep.
still predictive analytics is something that it can't do, right? Gen AI is still only limited to some scopes. Data scientists are solving predictive analytics. So these are different problems that they can solve. But if they really want to get into Gen AI and work on AI agents, I still see there's a lot of barrier for entry for them. Like, hey, can you do this? Because there's a lot of engineering that goes into this, right? It's just not about, hey, you have this model, you have MLOps workflow, you have these metrics that you define to see how your model performance is, logical regression models, and you have all
Yeah.
these statistical models that you build. That's what the data scientist does, and that's really important because LLMs cannot do that.
Yep.
People anyhow they're building AI agents that can do that now. They're building co-pilots for data scientists using LLMs, but still, predictive analytics is something that Gen AI cannot get into. It's a different domain altogether. It's a different area which only experts in data science could do. But for them to get into Gen AI is again engineering because no one is building LLMs from scratch. They just want to wrap LLMs, use MCPs. But the biggest thing is the evals that goes into these LLMs, right? When you have your AI agent, you build AI agent, it doesn't take a lot of time, but how do you evaluate it? How do you know the output will be right 95% of the time, right? That is where you
Yeah,
feel
that's
like that
tricky
is
for
experimental.
LM. Yeah, when you do a
So
feedback.
Yes, the data scientists would have that experience of experimenting with different data sets, but their software engineers doesn't have that mindset. So they have to change that mindset and get into eval. So that's the reason why if someone's coming as a fresher like you, always try to like do some projects out there, put it on GitHub, maybe create a YouTube video on showing how the eval work. I'm telling you, there's so many there are a lot of jobs out there which are looking for that skill set. It's just
Yeah.
that, it's just that, there are a lot of people not doing that, or maybe, and also this is a dynamic area. Every week something new comes, so you need to learn, keep on learning, keep on being
Yeah,
curious.
we need to find the focus. That's really
It's
one
going
Absolutely,
thing.
very, very
Yeah,
absolutely.
fast.
you need to
I
Yeah,
have
this,
a question, Raj, I have a question.
yeah,
Like,
you're on.
this is one way that, I mean, by implementing it through code, we can integrate multiple agents together, right? That is one way of
Hmm.
doing it. Another easy way, which is coming into the market, is like using n8n. So, like, we can do a lot of
Hmm.
automation and we can utilize so many tools together. So, what are
Hmm.
your thoughts in it? Do you think that what we are
Hmm.
achieving through multi-agent and reasoning can be achievable through n8n agentic workflows as well?
See, I mean, n8n is a no-code tool, right? n8n
Yeah.
is basically, it does have a lot of plumbing. Like, let's say you want to create a simple workflow, someone is not a developer. It's a barrier to entry to build agents is very low. I know a lot of people in Charlotte, like they're coming from like financial domain, and they are even someone who's coming from civil engineering, but they have their own consulting businesses building off n8n. So the barrier for
Yes.
entry to build n8n solutions with n8n is definitely great. I mean, I'm seeing a lot of them benefiting out of this. But yeah, at the end of the day, when and this plumbing is happening because a lot of tools already can create some credentials. You can create this authentication and all, and n8n is a hosted service because they only have some executions. But you can also spin n8n yourself in your own local, but you cannot have that commercialized. So it has some licensing as well. It's not purely open source, but it also has some licensing aspect to it. So a lot of firms, they like to do things programmatically because n8n as a software, we don't know how they're building that software, right? I mean, yeah, it's open source. The code is open. Someone has to review that. But what if I can just build my own LLM and have my own code and I create my own existing auth in place? So in enterprise it's very difficult to do this, and you can't have anything do all of this for you in an enterprise setting, right? Because you have some guardrails that you need to follow. But someone to just get started with agents to do simple workflow, they can. And as far as n8n, we don't know if it's scalable or not. I don't know under the hood what they're using, but if there's a huge traffic, you have someone, maybe a travel agent that you want to build with n8n. It's very brittle in the sense that it's all sequential. Even if you want to parallelize, you could do parallelization, but that might be expensive when compared with having a Kubernetes or your lean code that is working. It's very great to create an MVP or create an ad hoc ad creator or digital marketing agents for maybe a small business, only for that business, right? You're not developing that as a SaaS, so you can't expose that as a SaaS. Rather, you can just have that working internally for that business, doing some ad hoc research and everything, and giving you a proper content that day for automating. That's great. n8n really works, and a lot of adoption is there for n8n now. So that's where you have a trade-off: either go with n8n or to develop your own code. So and someone who's coming like I am. I mean, I always go with code. n8n is simple for me, but still, I mean, for me, it's really difficult because working with code is easy for me, but n8n, it has all these connections that I have to make, right? I mean, I used to work with something called Confi UI. I don't know if anyone knows that. Confi UI also has similar kind of thing. It's very easy to build something in n8n, but as you build complex workflows, it becomes so huge. You have to mentally go ahead and see which connection goes where. Maybe some connections are really complicated and you don't know when you click something, it might go and mess up something else. That doesn't happen when you create complex code, in code, as code, complex workflows as code, because now with code, you have version control, you have visibility, you know how the code changed sequentially throughout the history. You can roll back if something really messed up. I went and maybe changed some connection, maybe on n8n. I don't know. I might forget. I maybe have to go back and do some versioning for that. But in terms of a code, you could always do that versioning really well. So I think
And
that's
yeah, you
a
have like modular, so you can create like modules by one and then integrate them
absolutely
together. Yeah, makes sense.
yes. Yeah, but it should not. I'm not telling it's a bad tool. It's a really great tool for anyone to get started with AI agents because it's definitely lowering barrier for anyone to learn and build AI agents. So we do have in Agent University, we do have some modules which are mainly for N8N, and we previously did some training as well on N8N, some modules that we released on N8N as well. If someone want to do some no code integration, yeah, it's a great thing that anyone can do.
Are you doing any kind of session on multi-agent workflows like using code?
Using
Using code? I mean, in
Yes,
code.
I mean we did bunch of them previously. Like I think previously this year, like in February, March of this year, I did. But we will plan for some few more next in the next few weeks. I'm creating some a multi-agent system on AWS. So, but most of them being cloud. But I'll we are going to do that on the cloud environment. But if you
That
want
would
to
be
do it
great,
on your
actually.
Yes, next week we have AWS Builder series. It's a series called Agent Core. So AWS provides Agent Core as a service. So it's just that you can interact with Bedrock, but it's more in the agentic space. So you can actually use all cloud native services to build this on AWS. So it could be LangGraph or it could be Crew AI. All of these could be built on AWS, but also using AWS native services for auditing and all of them, right? So that is something that that is a thing that they have introduced with Agent Core. You know,
So
they
like
want to,
with
yeah.
agent AWS Agentic Core, like is would that be possible? Like I have a database in Postgres on AWS, and I want to like attach a chatbot to which if I give a human readable query, it can go and query their database and pull in the data in a meaningful way, or like I mean, or like vice versa, like as like a natural language query can be given and the data is fetched in a form of table or things like that.
Yes, you can do that. That I think that's even better because now you're dealing with databases and you have all of these AWS native. So imagine now you have this code. You can also create IAM role for that to just have limited read-only permissions because now you're reading the data. So even if the service has to go ahead and probably doing DDLs, it will not allow because you have a role to that specific thing, right? So that's the beauty of AWS Bedrock Agent Core is it could be any of this code implementation that you have, but also you can add those guardrails, which is AWS native guardrails into this. Like you can have IAMs to secure that process and all. So you could do
Which
that
one,
with
which tool can help me to do this translation? I know there are tools like that can help to like get the human readable query question and like query the database and brings back the data. So are there any in the sessions that you are going to deliver, will there any tools that we will be covering? If so, that would be really awesome.
Yeah, I mean, you could use any LLM on AWS Bedrock. If you have access to AWS Bedrock, has so many LLMs. You can use any of those LLMs to do this.
But I think there would be some special, as you mentioned, like
Layer,
mm,
maybe orchestration layer like Llama, LangGraph or Llama Index. These are things that you are looking for, or the programmatical way of interacting with it, or
I mean, when I was like doing kind of research a while ago, so there was a special library. I don't
oh,
exactly recall that
yeah,
is.
there are a lot of there are a lot of libraries and that you see so many special libraries because everything is a wrapper around something. So if you want to
Yeah,
do
so
something like
those
that, just
LLM
go
will
ahead.
be trained for
Yeah.
like databases specifically, but I don't know
Oh
which
yeah.
one is. Yeah, so
You
I'm
have
like,
Mistral SQL. It's
I
called
think this was
Mistral
the one
model. Yeah, it's a Mistral 7B. It's actually trained on that. Snowflake also has some done. It's called CodeStrill. CodeStrill. So it is also a good open way to generate like different I think SQL generation. So they a lot of SQL generation evals are also there. So you can just check, but you don't have to start with like state of the art. You can just start off with a simple LLM and eventually fine tune it. You could do that,
I
and we
want
did
to
it that.
actually, I'm working with databases and I want to like, and I have like some experience with RAG as well. So I want to do like less effort, but I want to quickly get some like chatbot kind of thing that I can like
Yeah,
present
to your
with,
client.
yeah. Yeah,
You
just
could
for
go ahead and use, yeah, you can use this. I mean, this is a solution that they just published. You can probably
which
use
one?
this.
Which one? Can
I
you
just
please
sent,
share it? Okay,
yeah, I
did
just
you
sent you
send it to me?
I sent it to you in the chat, in the meeting chat. Just look at it. It's just doing the same
Okay,
thing. They have Postgres and everything, so you can just see, and it's also from AWS, so it's already validated from them. So you can just
nice.
go and use this step by step.
Yeah, I think I'll experiment that. Thank you so much.
No problem.
This
So where do you
session has
work
been
at?
great. Path Robotics.
Pax Robotics?
Path Robotics.
Path, P-A-T-H?
Yes.
Oh, Path Robotics. Okay, sounds good. I mean, yeah, robotics is really doing great now. But I think it's a welding systems for and all of that. Okay,
Yeah,
that's
so I
nice.
finally, yeah, before that I was working in TikTok last year.
Oh, that's nice. Yeah, I know a few who work there in TikTok. I think I met a
Yeah,
few
but
of
the
them.
TikTok ban situation is not cool at
I
all.
know. But now I think it's not banned, right? It's just the people are using it probably like
Yeah,
it's
it
just
is.
transformed.
Yeah.
Um, okay. I think it's a
I
great
sent you
session.
a
I mean,
connection request on LinkedIn as well.
absolutely. 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 I think, yeah, thanks a lot, everyone. I mean, we went over 8 minutes, but yeah, I enjoyed the session a lot. As always, I mean, we stay tuned to our Luma calendar. We'll have a few more sessions coming up very soon.
Sure.
Thank you.
Thank you
Y'all have a
so
great
much.
day.
Thank you.
Bye.
Thank you, everyone.